You know, you're almost done your math class. It's been a lot of work, but it's paid off. Every new unit is like a new chance. At this unit's gonna take you, but we're gonna do it together. You put a lot of work into this, and now it's paying off. Hi class, welcome to the second to last unit of Math 10. We're going to be looking at equations of linear relations here. We're going to talk a lot about the slope. We're going to learn about linear relations in three different forms. That's the slope y-intercept form, the point slope form, and general form. And we're going to relate linear relations expressed in these forms to their graphs, okay? So we're also going to be able to determine the linear relation given a graph, a point, and the slope, 2 points, a point in the equation of a parallel or perpendicular line. All right, here looking at warm-up number 1, I have graphed out a few relations here, okay? So take a look at these relations and their graphs. And what I want you to do is to list the linear and non-linear equations here. Okay, so take a look at these, list the linear and non-linear, then compare the lists and write a rule from the equation which can be used to determine whether the graph is a straight line or not. Okay, press pause now. Okay, so we're back, and I took a moment to show you right up here what is linear and what is non-linear. Hey, I can see a line just as well as you. Okay, so we've got the first two are linear, these two are not linear. It's not a straight line, okay? We got two more linears here, this one and this one, okay? This one is not linear, neither is this relation, okay? I've written them out here, and then I've made myself a rule. If the exponents of the terms in x and y are both equal to 1, the graph is a straight line. That means that if we see an x, okay, we assume that there's a 1 there, okay? We don't have to see it. But if we see like an x squared or an x to the third or a y squared, all right, then we know that these are not going to be straight lines, okay? When you see that square, not a straight line. A linear equation is an equation in the form y equals mx plus b, where m and b are elements of the real number system. And the graph of a linear equation is a straight line. All right, so we've got Janine here using a graphing calculator. She graphs this equation out. She gets this, okay? I want you to complete A, B, C, and D, just looking at what she's found and answering the questions. Press pause now. So here what we're really doing is just comparing the equation here with what we found with this line, okay? So we use the idea of rise over run, and we find that it rises up 2, okay, and then it goes over 3, the run is 3. So we find the slope of 2/3. We see where it intercepts the y, and it intercepts at 0, -1 here. So the y-intercept is -1. Now it says compare the values found up here in A, which we used this graph to find, with the coefficient and the constant term. Well, here's the coefficient and here's the constant term, and these are surprisingly similar to what we found here and what we found here. So we can make a general rule that the slope is the coefficient of x, whatever's in front of the x, and the y-intercept is the constant term. Okay, this makes everything super easy. Let's check this again though. So now we've got two more equations, two more graphs. First of all, y equals 2x plus 1. So we're going to go up 2 and over 1. The slope is 2. Hey, look at that. Okay, y-intercept is 1, 1, and I see a 1 here. Okay, let's take a look at this graph, this line right here. We go over 2 and then up 1, 2, 3, 4, 5. So our rise is 5, okay, and it's, let's call this a negative rise and then a positive run. So that would be negative or positive. It would make it a negative. This is surprisingly similar to what's right here. And then the y-intercept of -3, which is right here, is right here as well. So let's make a conjecture about all this. The slope is m and the y-intercept is b. Okay? Now what I'd like you to do is take a look at warm-up number 3. I want you to use the sketch to determine the slope and the y-intercept of this graph, and then explain why in this case the slope is not 5, which is the coefficient of x, and the y-intercept is not 8, even though this is what we see here. Press pause now. So here we have Hashib's answer. So the slope is, well, let's count. Rise is 5, and then the run is 1, 2. So the slope is 5 over 2. The y-intercept is just right here. So the y-intercept equals 4. So it looks like our rule doesn't work because, hey, we don't have a slope of 5 or a y-intercept of 8. But the coefficient of y is 2. So that makes it a problem. Now, if we divided everything by 2, it would work. So the equation needs to be in the form y equals 5 over 2x plus 4. The equation has to be in this form with y with no coefficient, okay? If we do have a coefficient, we're just going to have to divide by whatever that coefficient is, because 8 over 2 actually equals 4, which is what we see right up here, and we see 5 over 2 right there, okay? So what I want you to do now is take a look at these, and I want you to determine the slope and y-intercept of each linear equation listed below, and then I want you to consider this right here. State the slope, make the y-intercept on the grid, and then make 3 other points, join the points together, extend the line, and then verify the graph. Press pause right now. So here we go, back with class exercise number 1. All I did was I just basically copied here. So we see a lot of the information up here. So first of all, the slope for A is 3, and I see it right there, and the y-intercept is 2. Here we've got them backwards, okay? So the slope is over here, and it's actually -2/3, and you can see the negative there. And the y-intercept is 7, the one without the x. And then over here, I just took the equation, I divided it by y's coefficient of 6, and so my slope is 4/3, which is just really 8 over 6 reduced, and then my y-intercept is 1/6. Taking a look at this one right here, now we're going to work backwards. We're going to take a look at the equation, which is what we did. We determined the slope, which is 2, the y-intercept, which is -5, and then we find the y-intercept on the grid, which was right here, and then we just started counting up. 1, 2, and then over 1, put a dot. 1, 2, and over 1, put a dot. 1, 2, and over 1, put a dot. And that's how we can draw the graph from just having an equation, all right? And so you can verify it by just checking and just making sure that it is correct. That is the correct rise over run, okay? So lastly, for lesson number 1, I want you to consider this equation, okay? State the y-intercept and then do the same thing. Put it on the graph, okay? So really quickly, we've got a -6 here, so you're going to start here with your y-intercept at -6, okay? You've got 2 over 3, a 2 rise, 1, 2, and then 1, 2, 3, and finish the graph. Go ahead. Okay, so we have the y-intercept of -6, okay? And we actually were asked to determine the x-intercept algebraically. That means put a 0 in for y, okay? So I've put a 0 in for y. 0 equals 2/3 x minus 6. We put the x on the other side and make it a positive, okay? Or add 6 to both sides. Now we have 6 equals 2/3. Can I multiply both sides by 3? Yeah, I can. That'll cancel these 3's out. This is 18 equals 2x, okay? Divide by 2, so x equals 9, all right? So that's my x-intercept right here. So if I have a dot here and a dot here, I can just draw a line, and I don't have to do these steps here at all. I just draw a line between the y-intercept and the x-intercept, and then I am done. And so here's our line. Now I want to switch over to lesson number 2, so let's head over there. So now we're here at lesson 2. We're going to be writing equations using this equation there, y equals mx plus b. The first thing is that you've been asked to write the equation of a line passing through point 0,2 with this slope. Now keep in mind that we have an x of 0, so that means the y-intercept is 2. So let's not make it too complicated. This is just y equals 5 over 2x plus 2. So let's move on to class exercise number 2. Each line on the grid passes through points with integer coordinates. In each case, state the slope and y-intercept of the line and determine the equation of the lines right here. Press pause and check out these lines and try to do that. So taking a look at these lines, here's line number 1. We've got a y-intercept of -4 here. And let's check out the slope. We've got a rise of 1 and a run of 3. So let's check it one more time. A rise of 1 and then over 3. Good. So we can say that that is a 1 over 3 slope. Y-intercept of -4. Here's the equation. It's as simple as that. Let's look at line number 2. We've got this y-intercept here. It is at 2. Okay. And then let's check the rise over run. Okay, it's a negative slope. We can see that. So we're going to go down 1, 2, 3, and then over 2. Yep. And then 1, 2, 3, and over 2. And we're following the line down. That gives us a -3 over 2 slope. Okay, so then this is our equation. All right. So I want you to try class exercise number 3. Determine the equation of the line parallel to this equation with the same y-intercept as this, okay? And then the line passing through this point and perpendicular to the line that joins these two. So now you got to use a little bit of what we've learned from the last unit and this unit, put it all together, see if you can do that. Press pause now. Okay, we're back looking at class exercise number 3. It's real quick. The line parallel to this equation means that it has this slope. If it has the same y-intercept as this one, it's got this. So we just put those two together. Y equals 1/3 x minus 7. We are done, okay? Now this one, a little bit more difficult. If we're joining these 2 points, then we've got to find the slope by taking this 0 and subtracting a -6. So that's adding a 6 and then taking this one and subtracting that. Okay, so that's going to give us a slope of 7 over 6. So the y-intercept is right here. It's going to be 0, 9. So the y-intercept is 9. Our equation is y equals 7 over 6x plus 9. Not too difficult. Now, class exercise number 4. The diagram shows the display from a graphing calculator screen. The intercepts are integers. Determine the equation of the line shown. Why don't you give that a go? Press pause now. So class exercise number 4 is a little bit more difficult unless you check out that we have an x scale of 5. So here is 5, 10, 15. So we're at 20 with our x-intercept. And here we have a 7, a scale of 7. So this is 7, this is 14 for our y-intercept. So we have a rise of -14 and a run of 20. And that's just saying, okay, -14, so we're going down 14. And then we're going over 20. That gives us a slope of -7 over 10. And we have this 14 as our y-intercept. So the equation is this. Now, try this with horizontal and vertical lines. I want you to take a look at these just so that we can establish some ideas about horizontal and vertical lines. Try to work through A to F. Press pause now. Okay, so here we have line number 1. The slope is a 0 slope and the y-intercept is right here, so that would be 4. Okay, so if we wanted to use the y equals mx plus b form, then we would write it like this: y equals 0x plus 4. Hey, why write the 0x when we can just say y equals 4? So that's what this one would be, y equals 4. So let's take a look at line number 2. Well, this would be y equals negative 6, okay, because that's where it is, all right, at negative 6. When we look at line number 3, hey, there is no slope that we can define, okay? The slope is undefined, and it never touches the y-intercept, so there is no y-intercept. So because we do not have a finite value for m, we cannot use the form mx plus b. When we talk about line number 3 here, all we can do is just say, all right, well, it's got an x-intercept of negative 3, so we would just say x equals negative 3. Why can't we use a graphing calculator? For a graphing calculator, the equation needs to be in the form y equals mx plus b. The equation y equals k represents a horizontal line through 0, k, and x equals k represents a vertical line through k, 0. So that's just an easy thing. We just say, hey, y equals 4 or x equals negative 3. All right, why don't you just take a second to work on class exercise number 5. Determine the equation of the line through this point and parallel to the y-axis, parallel to the x-axis. Go ahead, press pause now. And here we go with the answer. Because our x is negative 2 and it's parallel to the y-axis, that means that it is going along a vertical line. Okay, so x is 1, 2, we call this x is negative 2. All right. Okay, and for this one, if we've got our coordinate plane here, we're going -2 and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. All right. So we're going to have a line here that is parallel to the x-axis. We're just going to call it y equals 8. And that is lesson 1 and lesson 2 on linear equations.